Professor Wyman here with a little study design overview. Now, if you'll recall from lecture, we've talked about a lot of different components of study design, but study design is just referring to how you're going to answer your research question. And you need to consider a lot of things like, are you looking at causation? If you're interested in causation, you want to know if one variable has an effect on another, you need to manipulate your independent variable. Are you looking at data collection over multiple time points, or are you just measuring it once? What's your sampling method? Are you going and getting an actual random sample from the population? Unlikely, probably have to do some convenient sampling. Are you studying one person, multiple people, multiple groups? How do you create your groups? There's a lot going on here. So what I want you to really focus on is this idea of internal validity and basic research designs. So we're in this class really focusing on this really basic idea of causation and how much causation we can attribute to the study. So we have here, you should recognize this from lecture, we have this overview of internal validity. So internal validity is, you don't just say like, this study has perfect internal validity or assign a number to it. It's this judgment based on elements of your research design. And internal validity is this concept of how much confidence you have, how strongly you feel that your independent variable actually caused or had an effect on your dependent variable. So we talked about some basic designs. The first is non-experimental. And so really, truly non-experimental, we're talking about correlational research. And there's no manipulation of an independent variable. There's also no controlling extraneous variables through random assignment. So non-experimental research, we don't have any confidence. We have really low confidence that our independent variable caused a dependent variable or had an effect on a dependent variable. So this is on the lowest end of the internal validity. All we're doing is measuring. So we can't manipulate something and then say, oh, this happened because of it, because we're just measuring. Quasi-experimental, it's actually technically still non-experimental because it's not a true experiment, but we separate it because here we do have manipulation of an independent variable. We're still not controlling our extraneous variables, so there's still no random assignment, but we are manipulating an independent variable. And so we have a little bit more confidence that our independent variable has an effect on our dependent variable. And then experimental, we have manipulation of an independent variable, and that has to happen before we measure our dependent variable, right? We're manipulating that independent variable, we're changing something, and then we're going to see if that had an effect on our dependent variable. And then we have this idea of random assignment. So it can be to order of conditions, it can be to conditions, but the key is that we're controlling our extraneous variables. And there is a separate video on extraneous versus confounding. But the basic idea is that we're isolating our independent variable and our dependent variable, and we're trying to look at the connection between them and not have any other variables potentially affecting that. So let's look at some examples. I'm going to draw. I know you guys love my handwriting and it's even better on video. So example 1, participants' stress levels after they received yoga therapy were compared with their stress levels before they received yoga therapy. So let's break this down. We are looking at manipulating when we measure stress levels. So there's an intervention here. So we have participants' stress levels. This is what we're interested in. This is our dependent variable because we're measuring it. So dependent variables, stress levels. And then we're looking at after and before they have this yoga therapy. So you can see here, we are not talking about different groups. So there's only one group here. So we cannot randomly assign to groups. So we have one group. And we have a before and after measurement of the dependent variable. So we know that we have a pre-test, post-test. This is a specific type of quasi-experiment that we've discussed quite a bit. So we have a pre-test, post-test. So in this example, our independent variable is actually the time that they took the dependent variable, the time that they were measured on the dependent variable. So our independent variable, you can call it before and after. I'm going to refer to it as time. And so that's what we're changing, is when they're measured before and after this yoga therapy. So this yoga therapy is our intervention. So this is that weird example we've talked about where the independent variable is actually time. This is just the intervention. So we're intervening. We think we're going to help stress by using this yoga intervention. So how we look at this in terms of experimental requirements. Remember that an experiment needs manipulation. So do we have manipulation in this example? Think about it. Yes, we are manipulating the time that they take that dependent variable measure before and after our intervention. So our intervention of yoga therapy, we are manipulating. So we can say, yes, manipulation. But if you didn't already identify this as a pre-post, pre-test, post-test, you might look at this and say, okay, well, the second thing we need to do is we need to control for extraneous variables. So are we controlling for extraneous variables? Are we using random assignment to groups or to order of conditions? So thinking about our extraneous variables and thinking about this, again, this random assignment, are we randomly assigning to groups? No, we don't have groups, right? So we are not randomly assigning to groups. Are we randomly assigning to order of conditions? No, there's no order. Everybody does the same thing, right? So the problem here, and the reason why this isn't a true experiment, is that something else could be the reason why their stress levels are decreased. So maybe doing anything before or in between stress tests would decrease stress levels. Maybe any activity would have resulted in lower stress level. Maybe everyone in this group did their stress test and then they went and did yoga and then they got some ice cream afterwards. And the ice cream actually reduced their stress, and then they take the stress test and lo and behold, they have reduced stress. So something else could explain it. And the reason why we're not able to control that is that we don't have multiple conditions or groups that we could look to compare and have a control condition. So this is an example of a quasi-experiment. So this is quasi-experimental because we do have manipulation, but we do not have random assignment to groups or order of conditions. And so we're not controlling all the extraneous variables. So moving on, we're going to go ahead and look at another example. So example 2. Mario wants to compare attitudes toward the Supreme Court between men, women, and non-binary students at Fresno State. So again, let's break this down. We're looking at attitudes towards the Supreme Court. And we're looking at gender, right? So we have men, women, and non-binary. So when you look at this, let's identify the independent variable first. Can attitudes toward the Supreme Court change your gender? Absolutely not. Gender is then independent of attitudes about Supreme Court. So that's going to be our independent variable. That's not ever going to change because of attitude toward the Supreme Court, right? But it's possible that gender could have something to do with attitudes toward the Supreme Court. So we're going to make, I'm going to call it supreme, just so I don't have to write a lot. So this is our dependent variable, attitudes toward Supreme Court. Now, the independent variable, are we manipulating it? So think about that. Are we manipulating this independent variable? No, we're just measuring it, right? We're not doing anything to manipulate gender, and we can't manipulate gender. We can't assign somebody to be in the man group or the woman group or the non-binary group. It's a pre-existing characteristic of our participants, right? So we're just measuring, so it's non-manipulated. So this is called a non-manipulated independent variable. So already I know if I don't have a manipulated independent variable, this is a correlational study, because that is the requirement. You have to have a manipulated independent variable for a quasi-experiment and a true experiment. So this is correlational. And let's continue to look at this though. So here we now have our dependent variable. This is also measured. The question is, are we controlling any extraneous variables? We're not doing any random assignment to groups. We don't have any groups, right? So no groups. We're not randomly assigning to order of conditions because we don't have any conditions. So we are not making any attempt to control for extraneous variables, and we're not manipulating. So again, this is our correlational study. And even if this is a D relationship, right? Because we're looking at groups, we have differences between groups. So differences in Supreme Court opinion between men, women, and non-binary students. This is a D relationship. But an R relationship would be the same thing. So you could change this a little bit and say, Mario wants to compare the attitudes toward the Supreme Court to masculinity of Fresno State students. And you could measure masculinity on a scale. And then you would have two scales and they would be both measured again. And that would be an R relationship. But this is an example of a correlational study. We're going to go to our next example. So example 3, researchers randomly assign participants to be in either a high background noise or low background noise condition, and then measured their ability to concentrate. So what we're going to do is, again, let's start at the beginning. Let's look for our independent variable. So our independent variable happens no matter what the dependent variable is measured as, right? And it's what will happen first, and then we would do some measurement. So we have either a high background noise or low background noise condition. So our independent variable, oops, here we go. Our independent variable is background noise. I'm going to call it BN, background noise. So we have two levels of our independent variable. There's low and high. And we are manipulating this. So we, as the researcher, are assigning participants to be in either the low or the high condition. So that is something we are manipulating as the researcher. And then after we've manipulated, we are going to measure their ability to concentrate. So our dependent variable is concentration. We think that concentration is dependent on this independent variable. So we think that something about these conditions is going to have an effect on our dependent variable, right? So here we need to say, okay, we have a manipulated variable. So we know that it's at least a quasi-experiment. How do you know that it's an experiment? Random assignment. So really it's about this idea of controlling your extraneous variables. What we're trying to do is we're trying to isolate the effect of the independent variable on the dependent variable so that we can be confident that the dependent variable was actually affected by our independent variable. So let's talk about random assignment. Random assignment in this case is to either a high background noise or a low background noise condition. So what we're doing here with our random assignment, this is to groups. So this is a between subjects experiment, random assignment to groups. We are controlling our individual level extraneous variables. So we are controlling individual extraneous variables. So we think that this random assignment is going to even out differences on people's concentration ability to start with. So their baseline concentration level, we're going to get about the same number of people that are really good at concentrating in both conditions, in this high condition and this low condition. So that way it's not affecting our outcome. It's not affecting this concentration after the manipulation. So you would end up having about the same number of men and women non-binary in each condition. You would have about the same number of people who are stressed out, or different levels of stress would be kind of even out between these conditions. So this is an example of a true experiment where we have random assignment to groups and we have manipulation of this independent variable. And this is a between subjects design. So there is a different video that talks about between versus within, but this is between. So let's stick with between. If I were to change this, I could say that for within subjects, everybody would experience all conditions and we would randomly assign the order of the conditions. So let's look at another example. Researchers posted signs normalizing mental health at Fresno State, but not around San Francisco State. Later, they measured the mental health attitudes of students at Fresno State and San Francisco State. So again, let's take a look at this. What's our independent variable? Posted signs or not, right? So let's call our IV equals signs. And really, it's about normalizing mental health. So to be more accurate, we could probably just say normalizing. So are we normalizing mental health or not? And by normalizing, I mean making it normal. So a problem with mental health is there's a kind of negative stigma about it. There's this negative association. So sometimes society thinks that people who experience mental health issues are weak or not as good, whatever it might be, right? There's these stigmas attached to mental health, but that's absolutely not the case. Everybody has challenges with mental health in different ways, and it's normal to have those issues. So the goal of this study is to see, can we help with that normalizing mental health? So we are manipulating, as the researcher, we're manipulating this condition of normalizing or not normalizing. So we're adding some signs that help normalize mental health. So that would be our independent variables, these two conditions. So we could say normal and not normal. Those are our two conditions. So we do have a manipulated independent variable, right? We're assigning people to be in one or the other of these conditions of the independent variable. So we could say manipulation, check, we have that. So now our question becomes, are we controlling our extraneous variables? So looking at this, we need to look at our groups. We need to look at what's happening here. So we're talking about posting signs at Fresno State versus posting signs at San Francisco State. So Fresno State, San Francisco State, these are our two groups. Did we randomly assign these groups? No, they're pre-existing, right? So there could be other potential explanations about our participants that could explain if mental health attitudes were better for Fresno State students. So let's actually look at some examples. So Fresno State, San Francisco State tends to have more. Sorry, I'm losing my train of thought here. So San Francisco State, for example, could have more mental health resources, right? So if San Francisco State has more mental health resources than Fresno State, or vice versa, that's a difference between these two groups. So we're not controlling for extraneous variables. So what could be happening here, and I'm going to clear this, but let's say that we measure the difference. Let's make this prettier. Okay. We measure the difference between attitudes towards mental health between these two groups. So we have Fresno State and we have San Francisco State. And I'm going to say this is our positive, negative attitudes toward mental health. And we're going to say that San Francisco has more positive attitudes than Fresno State after this study. So what explains that? Are we confident that it's our signs, that it's our independent variable that had an effect on San Francisco State? So if we have, oops, I did this backwards. Let me clear this. Sorry, guys. Okay, so let's do this again. We have Fresno State and we have San Francisco State, right? So what we're seeing here, again, with our positive and our negative, let's use our actual information from up here. So we have mental health at Fresno State. We do have the signs, right? So this is our no signs condition. And this is our signs condition. So we would expect that Fresno State, if this actually worked, if this little intervention, if this test worked, we would think that Fresno State would have higher mental health perceptions or more positive mental health perceptions than San Francisco State. So what we want to see is if we have good internal validity, we would be able to say that we're pretty confident that it was actually the signs, that it was that actually created that difference, that caused that difference. So if we were confident in that, then we could say, hey, it's our independent variable. Our independent variable had an effect on our dependent variable, right? So this level here, this is our dependent variable. We think that this is higher for Fresno State students because they had these signs. Well, because they're different, we didn't randomly assign people to groups. There's pre-existing differences between Fresno State students and San Francisco State students. So maybe the alternative explanation is that Fresno State students in general just feel more positively about mental health, that they just feel like it's more normal than students at Fresno State. So maybe they're just different baseline. So we'll say different baseline. Maybe Fresno State students have different resources. So we'll say more health resources. There's a lot of different potential differences between these two groups. And so it's not just a difference between signs and no signs that we're looking at. It's a difference between signs and no signs and group differences. So how do we know that it's the independent variable that had an effect on our dependent variable? Or is it just a difference about the populations that we looked at, a difference about the groups that could explain that result? So this is why with a quasi-experiment, this is a non-equivalent groups design. So this is a non-equivalent quasi-experimental study. This is why we don't have as much confidence that our independent variable caused our dependent variable. So that is the end of this example. Make sure that you review your notes and let me know if you have any questions.